Investigation number 3 looks at the impacts of acid rain on soil. Historically, where we've had issues with acid rain, we've seen that forests have been decimated by it, and one of the reasons is that acid rain impacts the soil. And so the soil has a property called cationic exchange capacity. It has the ability to hold on to cations that the plants need as micronutrients. And so when we look at, say, for example, particles of soil, we see that it has negative charges on the clay particles. And those negative charges have the ability to hold on to ions such as calcium, magnesium, and iron. And those are required by plants for healthy growth. And so, since acids have positively charged protons, and by definition, an acid is a substance when dissolved in water produces H plus ions. And these H plus ions bind to soil and basically occupy those negatively charged clay particles. And because of that, those cations that are required for plant growth cannot be held by those soil particles. And literally, they are leached out of the soil, and those soils become infertile. And we see those plants dying because they lack the required nutrients that the soil should have been providing. And so the cationic exchange capacity of the soil is affected by acid rain. So in this investigation, it's quite simple. We're going to be using some nitric acid. And by the way, nitric acid is produced when nitrogen dioxide gas reacts with oxygen and water in the atmosphere to produce nitric acid. It is one of the gases, one of the acid rain forming gases that produce this nitric acid. And so we'll test the initial pH of the acid, and it is recorded in the data as 1.89. And then we'll prepare some soil. There's some soil here, and we're going to put 50 grams of it in a half gallon milk jug with a coffee filter. So pour soil in. Make sure it's there. And then after that, we pour our acid rain on our soil, and then allow it to drain slowly into a beaker below. And then we test the pH of the acid rain after it has gone through the soil. And so in your table, you'll notice that the pH increased to 2.06. Now, the higher the concentration of H plus ions, the lower the pH, the more acidic the acid is. And the fact that the pH increased, it meant therefore that some of the H plus ions are now binding onto the soil. And so we see that the soil has the ability to capture these H plus ions, and when they do so, the cationic exchange capacity, the ability to hold other important ions for plant growth, is inhibited.